source. And to measure the voltage and output of the our simulation, I will add the voltage measurement. So I will arrange the all component as a requirement. So I will require 6 MOSFET as three-phase inverter circuit diagram. I will copy the MOSFET and paste into 5 times and arrange it in upper layer 3 MOSFET and lower layer 3 MOSFET. And in MOSFET we have required only source, drain and gate pulse. And not required measurement. So I will rotate MOSFET as requirement. That is our source, drain and gates. This is a measurement. It is not required, so I will remove the measurement port. So you are only required last one MOSFET measurement port. So I will remove the all 5 MOSFET measurement port. MOSFET is a switching device which required gate pulse to trigger it. So I will arrange the MOSFET and rotate it clockwise for the connection. So I will arrange it with requirement. Then we will connect the MOSFET as requirement. So I will connect the DC voltage source, positive terminal of DC voltage source, to the upper layer drain terminal of MOSFET. So I will change the MOSFET names. First MOSFET name I will get M1, M3 and M5, and lower layer MOSFET I will change the name M4, M6 and M2. That means MOSFET M1, MOSFET M3, MOSFET M5 as upper layer MOSFET, and MOSFET M4, M6 and M2 are lower layer MOSFET. So I will connect the drain of the upper layer MOSFET, and then we will connect the positive of DC source to the upper layer drain terminal of the MOSFET, and negative terminal of DC source which will connect the source terminal of the MOSFET. And then we will connect the M1 source to the M4 drain, M3 source to the M6 drain, and M5 source to the M2 drain. And in load we will require only resistance, so we will modify it and we will select the 5 ohm resistance and apply and OK. So I will require 3 resistors for star connection, so I will copy and paste it. Then I will connect R1 to the MOSFET of M1 and M4 R2 is a MOSFET M3 and M6, and R3 is to MOSFET M5 and M2 at midpoint. So I will connect that. And then we can connect it as a star connection. We are connected parallelly R1, R2 and R3, and then we will require two voltage measurement between R1 and R2, and then we will require gate pulse to pulse generator for triggering of MOSFET. So we will copy pulse generator and paste it 5 times to so I will require 6 pulse generator for 6 MOSFET. So I will change the name of, and then connect with PG1, PG2, PG3, PG4, PG5 as required. So I will arrange it in MOSFET's order. And so I will connect the pulse generator to the gate terminal of MOSFET. PG1 is connected to the MOSFET 1, PG3 is connected to the MOSFET 3, PG5 is connected to MOSFET 5, and PG4 is connected to MOSFET 4, PG6 is connected to the MOSFET 6, and PG2 is connected to the MOSFET 2. And as we know, I will set the MOSFET parameter. We are know our Indian frequency is 50 Hz, and to measure the voltage between R1 R2 we will require two measurement source. So I will copy and paste it, and I will change its name. So I will arrange it as required. And then I will connect voltage measurement to the according R1, and I will change the name it as a load voltage. So I will copy and paste, and it connect across R2, R1 and R2 to measure phase voltage. And in the scope is only one terminal, so I will increase the input of the scope. For the
Voltmeter we will connect to the scope to we get the graphically output as VPH and line voltage. So then we need to trigger of the gate pulse with the sequence of 3-phase output. There are the we arrange the gate pulse as the sequence 1 3 5 2 6 4s. We will get the outputs. So I will enter the values at gate pulse once. At the gate pulse we need to with 0 angles. Period is 0.020. And pulse width percentage is 50%. Now we need to apply on the seconds gate pulse. Now we will trigger to the gate pulse 2 with 60 angles. Now we trigger to gate pulse 2. We need to change the value with 60 angles by 360 to get the sinusoidals output 3 phase. We same values we are put it in gate pulse ones, only change in the uh, with the 60 divided by 360 for the phase difference with angle 60. And now we change the value of gate pulse 3. Also will same values other and change the value of the 120 divided by 360, and periodic value will be remain same 0.020 pulse with 50%, and phase delay only change 120 to 360. So our India frequency is 50 Hz, and by per seconds will we get 0.020 to will put 0.020 to get 50 Hz output, and others remaining saying only change in phase delays to get sinusoidals output. Only change in the 120 to 180, other remain same. Here also same values 0.020 for 50 Hz. Phase angle we will change to 120. I will change to 240. And now need of change of the last pulse generator 6. These are the arrange in the 1 2 3 4s for the get the sinusoidals outputs here to 300s phase delay. Here connected to R load, 3 phase R load in this circuit. Now we'll save files in the PC to run this program. So I will start the program. These are the outputs of the scope. I will zoom it. So first is the gate pulse. So first waveform is the shows the gate pulse, and other first and second and third shows the phase voltage and line voltage of the waveforms. These are the trigger the gate pulse by the sequence 6 1 2 1 2 3 2 3 4 like this to get the balance 3 phase outputs. This is the output voltage. And there are the many types to change the voltage of the three phase at the outputs. There are the two main types, internal and external. Internal is we are changing the gate pulse values, we get the uh, output voltage will be changed. And external, there are we are use the voltage regulator at DC supply side, we change the supply of the DC, then we get the output voltage also change. And we also use of the transformers at output at the external side at the AC source of the step up and step down voltage with according to use. Thank you.